Hey, Dr. C here. Good to see you all today. I thought I'd do a kind of a reprise now. We, 3 years ago, with the start of the COVID problem, or pandemic, I guess, we had a show telling you a little bit about what to expect. You know, it's been 3 years since I've talked to you about that, and there's been so much material, so much misinformation, some good information, but I need to explain a large number of things to you because the reporters take for granted that you may know a lot of these things. For example, what is a virus? For example, what does it mean to be immunocompromised? You know, they take that for granted and just throw it out there. Well, COVID is still here. COVID will continue to be here. And so let's go through some of the things that I think are important for you to really know a lot about. So first of all, just to tell you a little bit about the numbers now, COVID has not gone away. There's still cases of COVID every day. We get them every week. It was interesting that I heard, I think 2 weeks ago, Department of Public Health from Worcester said, oh, we had no cases reported this week. Well, geez, what a ridiculous statement to make. You know, people now are taking the antigen test. They may come back positive, but they don't feel too bad, and it never gets reported. So what they should have said is that there were none reported this week. You know, that's just one of many, many things that irk me, you might say. Let's talk a little bit about the seniors now with COVID. We still are losing a lot of seniors, not just to COVID itself. Roughly in the United States, about 1 in 100 seniors have died because of COVID. 1 in 100. That's not a little thing. And we still had the flu, and it's still going on. Flu still goes on right through April. 90% of all of the flu deaths are over age 55. 90% of all of the flu deaths. Also, with COVID, if you look at the numbers, 80% of all of the deaths are over age 65, and 93% are over age 50 with COVID. You don't see that in the headlines, but that is what's going on. When we had the triple header, you know, the COVID and the flu and a respiratory syncytial virus. Respiratory syncytial virus was described as a kid's virus. What a lot of baloney. There were over 14,000 seniors dying each year from respiratory syncytial virus. 14,000 in the United States. That's not inconsequential. So we as seniors really need to be very aware of all of these things. And incidentally, just to complement a few things, all of the vaccines that we have received, especially now that so-called bivalent one that's out there, that was against BA4, BA5. You know how many cases of BA4, BA5 are out there now? Under 10% of each one of them. The main one now is XBB15, or 1.5, XBB. That's over 89% of all the cases. That ain't covered by the vaccine. So there's a lot of misinformation out there. Also, I have to mention this before I get into it. I looked up and see how much money did the drug companies make from this in 2022, last year. Wow. I'll tell you, Pfizer, which is the biggie, really, made $65 billion, with a B, $65 billion profit last year. Moderna sold most of their stuff to the governments and all. They were peasants. They only made 3.1 million last year. Now that the government purchases are ending now, both of those companies are stating that they will now charge for their vaccine $130 per dose. Now they charged the government $30 a dose, and the governments bought millions. But because they're poor companies, you know, so now they're 4 times the amount that they charged, all in 1 year. Isn't that something, huh? Okay, let's get into what we came here for. Do you know what a virus is? Well, look at this. First of all, look at the stars. On a clear night, you're going to see trillions of stars out there. Well, do you know how many viruses that have been identified? 100 million times more than the number of stars that are out there. That's the number of viruses that are there. Now, we don't know most of the viruses. Virology, when I was a medical student, that took 1 chapter in 1 book. It was really not very large. So there's a huge now expansion of knowledge of viruses, obviously. They are tiny things. How tiny? They don't even call them organisms. They just call them little microscopic packets. A packet of DNA or RNA. That's about it. And it has a coating. And that structural protein in the coating is the thing that they make vaccines out of. That is it. A virus can't propagate itself. It has to be in a foreign cell in order to propagate. How do they do it? They take over the cell mechanism. And that cell then produces a whole bunch of that virus again. So, very interesting things about virus. You measure them in terms of nanometers, billionth of a meter, a billionth. And they are in size just a little larger than an atom. They are only about 100 nanometers. You know, in 1 drop of water, you got more damn viruses than there are population in Massachusetts, for example. It is ridiculous how many of these things are out there. And so, what about the coronavirus? That is only 1 type of virus. And of course, that's what we know. We see the spikes. We see the spikes. It's supposed to frighten you as soon as you see those damn spikes. Now, not all of the viruses are round. In fact, even the round ones aren't really round. They have little squares on them all the way around. So it's not really a true circle. But they also come in the form of a rod as well. So they can be different shapes. But they all have specific proteins in that envelope around the virus itself. A little piece of protein. The thing that we know of in a cell, for example, you have a cell wall and you have a nucleus. Well, they have a nucleus too, which is, again, covered by a little envelope, and it's called a capsid. Now, that stuff that's inside the virus may be RNA or DNA. Of course, we have DNA. Some of them have DNA, some of them have RNA. The ones that we worry about are the so-called beta coronaviruses, because there's 4 types, alpha, beta, gamma, delta, 4 types of coronavirus. Only 7 of the coronaviruses are in humans. Most of them are in plants and different animals. But 7 of them can infect humans. And so, of course, we know about SARS, we know about MERS. They paled in comparison to coronavirus 19. Paled in terms of numbers of people who got it and number of deaths. And so, at any rate, that's for coronavirus at any rate. So let's talk a little bit about it. The coronavirus that we are concerned about, COVID, has different symptoms depending on which of the variants that are out there. And the symptoms are different in seniors than they are in juniors. I'm going to call young adults and kids juniors, okay? So that's okay. Well, we gotta distinguish between them. But what do seniors develop? They develop symptoms like simple fatigue. Fatigue. They may get, in fact, in nursing homes, they notice sometimes mental confusion in the seniors. They may be sleepy. They may have some nausea, vomiting, diarrhea, which sounds like another type of virus, like a norovirus, but it isn't. And so the seniors get dehydrated very quickly, so they're weak. So those are all the types of symptoms that seniors will have. They don't necessarily have loss of scent or loss of taste. Younger ones may get that, not generally the seniors. And so we also worry a little bit about, we worry a lot now, about long-term COVID. Now, why is that so important? 1 in 5 people who get infected with a coronavirus will have long-term symptoms. Now, what do they mean by long-term symptoms? Symptoms that last longer than a month after that initial infection. A month. Now, there are people who have long-term COVID for over a year, 2 years with symptoms. Now, there are particular places where that virus will hit, particular parts of the body, for example. So let's go through some of those with long-term COVID. The one that's the most common, actually, are neurologic symptoms. Headache, fatigue, brain fog. They may get some clots or little microclots, which will continue to spread in the brain, causing that brain fog. They may have trouble with neuropathy, feelings of numbness or tingling in the hands or feet. May have trouble with memory. May have trouble, again, with occasional loss of smell and loss of taste. And these can persist, these neurologic symptoms. No treatment for it. The second most common, respiratory. You may get short of breath. We call it dyspnea, but that's shortness of breath. With just a little bit of exertion, they may get short of breath. So they may get a chronic cough as well. Non-productive generally, non-productive. They may also get occasional anterior chest pains, unexplained. And it's a recurring thing. And so that is the second most common. And it does affect their work. So what's the third? Cardiac, heart problems. They may get some palpitations. Palpitations, irregular heartbeat. No explanation for it. May even get a pericarditis, especially the younger males may get pericarditis, actually. The fourth most common, GI symptoms. Remember I mentioned nausea, vomiting, diarrhea? That is probably related to the gut microbiome. The trillions of bacteria that are in our bowel, in our gut. And so they're just studying that now to see what the differences are with people who have COVID. Interestingly, too, with your biome, not necessarily the microbiome, the bacteria, there is also a virome, viruses that are in the GI tract. Remember, viruses have been around for thousands and thousands of years. They've infected humans, infected animals, infected plants. In fact, they've been so prevalent over the course of time and all that they are actually pieces of them that are incorporated into our human DNA. They estimate roughly 8% of our DNA consists of little pieces of previous virus that infected the human race. Amazing. I mean, we're just learning about that now. Just learning about it. So, what are all the things now that are out there to test? Well, of course, the most common one that's out there right now are the rapid tests. But remember, those polymerase chain reaction, polymerase PCR tests, especially the ones that use that reverse transcription. Well, what the hell is that? The reverse transcription. Remember how we make proteins. Our cells are turning over all the time in our body. They're turning over. How is it accomplished? The DNA has to stay inside that nucleus in the cell. The DNA stays in there. It makes messenger RNA. Messenger RNA can travel out of that cell. It then goes to transfer RNA onto ribosomal RNA, which goes into making a protein with the amino acids in the body. That's how we make our proteins all the time. It's working all the time. That process of making the DNA and converting that into a messenger RNA, that's called transcription. And that RNA can travel out of the cell then. So to make a reverse transcription, we have to make new DNA, reverse transcription. And that's how you identify the virus, the coronavirus. You're making enough of the DNA so now it can react positive on a test. So the most common test that was supposedly most accurate was the PCR, RT, reverse transcription, PCR. Okay. Now, the most common test that's used, however, because the PCR test takes a day before you get your report. The rapid one that's only 15 minutes, that's the one that's out there. And there's hundreds of companies making these antigen tests. That's what they are, antigen tests. Some of them are accurate, some of them are not as accurate. If it's a positive test, it's very accurate. However, there's only a 60 to 70% chance when you get a negative that it is truly negative with all of the antigen testing. The other type of test besides then what's the molecular test, the PCR, the antigen test, there's also an antibody test. Now, to do the antibody test, you have to actually have blood drawn. So you get the blood, spit it down, take the serum. You're looking for the antibodies, those antibodies that are floating in the serum of your blood. So then you get your specimen, dilute it, put it onto a plate. Now you have to also have that, now you put your serum on. And now if the serum, the antigen that reacts with the antibody that's in that serum, it'll be a positive test. That's basically how all these antibody tests work. There may be a little more rapid test that's out there. There may be one that takes 4 to 5 hours. The rapid test may take only 30 minutes that are out there. There's also ELISA test, ELISA, an enzyme leak test. And it basically works the same way. There's an antigen-antibody reaction on the plate. So those are the tests that are out there. So what else? The vaccines that are out there. Of course, the two major ones, the two messenger RNAs, they haven't been any new vaccine that's out there right now, even though they approved a different one. It's just a different mechanism. They don't use messenger RNA anymore, too. The new ones use either a viral adenovirus that gets into a cell, and they use that to get into the cell instead of having to make messenger RNA. The AstraZeneca that is still not approved here, but it is in many countries, they use a viral vector. The J&J is a viral vector, Johnson & Johnson. The Russian one, the Sputnik, they use 2 adenoviruses in theirs. And also now, there's one that just uses a protein, the protein that's on the surface of the virus. They call that the spike protein. Well, that spike protein has 2 components to it. The proteins that are in that spike are glycoproteins. It's sticky. I call them sticky proteins, glycoproteins. And they can get into a cell. They happen to be able to get in to the ACE2 receptors that are in our respiratory tree, ACE2 receptors. And so the pieces of that spike protein now will get in through that mechanism and get into the cell. It takes usually about 2 days before you get symptoms. Usually you get symptoms 2 to 5 days from the time the virus infects you. Once you're positive, then another 5 days you are infectious yourself. So you can spread it in the next 5 days. Now that is a general term. 2 to 5 days to get positive, 5 days that you quarantine. It could be a little longer with some people, but that's the general. Okay. So how do these vaccines and all get approved? How do they get approved? Well, they take that for granted, basically, that you know what these phases, they call them, of approval are. Phase zero, that's just the idea that something may work. So they may test people, not necessarily with the disease, but just test people to see, first of all, if it's safe to use. You don't want to knock them off, you know. And get an idea using a very small dose. So that's phase 0. That's not really a clinical stage. That's not yet. Clinical stage 1, they may use 20 to 40 healthy people, not necessarily with the disease, 20 to 40, figure on different doses, so they figure out the doses. And they want to figure out if any of them are toxic to the people. If they pass the phase 1, they go to phase 2, clinical study. Now they'll use several hundred people. Some of them have the disease. Some of them may not. And so they further then find out the effectiveness and the side effects of that vaccine. Now they go to stage 3. Each stage has to be approved by the FDA, Food and Drug Administration. Okay, so now we go to stage 3, where they use several thousand people who have a particular disease, and now they will use double-blind studies. Some will have it, the regular vaccine at a particular dose, and some will have just a saline injection or something. In other words, double-blind study. And now they really do test how effective that vaccine happens to be. So then after the vaccine is approved, assuming it's approved, only 10% of all the vaccines that have gone into phases. Only 10% are finally approved by the FDA. So, knowing that, they still continue to test it for long-term effects as well. Now, there are some things that we need to know about misinformation. Roughly about 15% of people are novids. In other words, they have never gotten infected. How come? What is it with these 15%? Is it in their genetics? How come they never get infected? They need to be studied, and some of them are being studied at the present time. Also, where do you get your information? A lot of people will get information from the WebMD. WebMD, that's very common. People will get it. Remember, WebMD is 100% funded by big pharma, by all of the pharmaceutical companies. You think you're going to get a straight answer from them? I don't know about that. Also, our federal government, this pandemic has been horrible on some of those big names, CDC, for example. And even Fauci. Remember, Fauci, he was a researcher. He wasn't on the front lines. He was a researcher, so he needed data. And you need somebody like that to head a big corporation like that, a big government agency. And he did a hell of a good job, he really did. But he did make some mistakes. Number one, he divorced himself from the World Health Organization. Not a good thing. He thought the CDC would handle everything. What a mistake. And what else? All the data had to first be confirmed by the CDC. Mistake number two. Highly politicized. That CDC became very, very politicized and had the media in its pocket. So they propagated a lot of this misinformation that's out there. So, to try to put it into perspective, what do we expect in the future now? Well, the manufacturers are targeting other proteins. They don't necessarily have to use that spike protein. They can use other proteins that are in the envelope of that virus, and that's what they're doing. And they may even target some of the stuff in the RNA that's within that capsid that's in there. Also, they may even make mosaics from them. In other words, they're using a whole bunch of different receptor binding proteins. They may even develop a T cell, one of the lymphocytes, the killer cells and all. They may develop a vaccine that stimulates more killer cells and all. So all of these are different approaches now to vaccines for the future. So I would expect that vaccines will not come out by this fall. I suspect it'll be next spring before we really see a lot of these new vaccines. And I'm waiting myself. I got my original 2, I got my 2 boosters. I am fine. And if you got that, you are fine, unless you are immunocompromised. So, okay, my time is up. I'd love to talk even more about this for the future, and I may. And this is Dr. C. Have a nice day.